Welcome back, friends. In today's session we are going to continue with our discussion regarding phenols, and today we are going to discuss about the electrophilic substitution reactions of phenol into the benzene ring. These reactions, they involve the benzene ring in a phenol, and they will be having some few differences with those of benzene as itself because of the properties of phenol which are caused by the presence of the hydroxyl group. So due to a strong positive mesomeric effect, the hydroxyl group activates the benzene ring towards the electrophilic substitution reaction at the 2, 4, and 6 positions. 2 and 6 positions, they are ortho, and position number 4 is the para position. Before substitution, it makes these sites more electronegative. Before substitution, it makes these sites more electronegative or more nucleophilic. More nucleophilic. Zina uwezo mkubwa wa kudonate electrons and so more easier attacked by an electrophile at these positions. Kwa hiyo inakuwa ni rahisi sana zenyewe kuwa attacked by an electrophile. Kwa nini? Kwa sababu zinakuwa zina high density of electrons as compared to other sites in the benzene ring. The activating effect of hydroxyl group is so strong that the aromatic ring becomes very reactive. Aromatic ring becomes very reactive under normal conditions. The substitution will continue until all favored sites have been substituted. Kwa hiyo hapa substitution reaction haiwezi ka stop, lakini mpaka labda uweze kubalance vitu fulani kwenye reaction ndio itaweza kustop, lakini otherwise the substitution reaction cannot stop until all the sites in the benzene ring they have been substituted. So mono substitution usually requires careful calculated amount of reactants. So monosubstitution usually requires careful calculated amount of reagents and specific conditions. Careful calculated amount of reagents and specific conditions. Tuanze na halogenation of phenol. Halogenation of phenol. A phenol reacts with aqueous solution of halogen such as bromine to form halobenzene. A catalyst is not required due to the strong activating positive mesomeric effect of hydroxyl group. In benzene, this reaction requires Lewis acid, for example, aluminium bromide or iron 3 bromide is a catalyst of the reaction. But in phenol, the reaction doesn't require catalyst, and the reaction tend to halogenate all the ortho and para positions. So the reaction tend to stop after the halogenation of all ortho and para positions. We have 2 ortho and 1 para position. All of these, they are halogenated in this reaction. Also the same thing happen even in the chlorination of phenol. Monohalogenation can be achieved if a careful calculated amount of the halogen is dissolved in a glacial acetic acid. Kwa hiyo ukiweka hapo ethanoic acid ambayo inaitwa acetic acid na ukaweka small amount of bromine, unaweza kufanya mono substitution either at ortho or at para position. After that, let's move to alkylation of phenol. Alkylation, tunakuwa tuna add an alkyl group. The normal process of Friedel-Crafts alkylation ambayo tulikuwa tunareactisha with an alkyl halide. Kwenye benzene tulikuwa tumezoea Friedel-Crafts alkylation of benzene, tuna reactisha pamoja na alkyl halide RX alkyl halide in the presence of aluminium X3 as the catalyst of our reaction. Kwa tunakuwa tuna reagent na huyu hapa ni catalyst of the reaction. Lewis acid ambaye ni catalyst of the reaction. This doesn't happen in a phenol. the normal Friedel-Crafts alkylation reaction kama ambavyo ilikuwa inatokea kwenye benzene cannot be carried out on phenol. This is because there are two nucleophilic sites. There are two nucleophilic sites in phenol, the oxygen atom and the aromatic ring. Oxygen atom ni nucleophilic site na aromatic ring ni nucleophilic site. Due to acidity of phenol, we record the formation of phenoxide ion, and the negatively charged oxygen in phenoxide ion will act as a nucleophile. The negative charge oxygen in phenoxide ion will act as the nucleophile, attacking the electrophile carbon in haloalkane. Kwa hiyo kitakachofanyika hapa ni kwamba itatengenezwa nini? Phenoxide ion, na ile alkyl badala ya kwenda kuattach kwenye benzene ring itaenda kuattach kwenye nini? Kwenye oxygen. Kwa hiyo itakayotokea tena hapo sio haitatokea tena alkylation of benzene ring as how we expected. So we must have additional conditions which will allow the alkylation reaction to occur in phenol as how it occurs in benzenes. Thus, the expected electrophilic substitution into the benzene ring to give an alkylated phenol will not occur. Instead, ether will be formed. Kwa hiyo in this reaction, kama tukiwa tuna phenol, alafu kwenye phenol tukareactisha na yule pale kama ambavyo tulijua kwenye normal benzene, kitakachotokea ni kwamba hapa itakuwa kuna formation ya phenoxide. Kutakuwa kuna formation ya phenoxide kama huyu hapa. Na ikishatokea phenoxide, manake presence of this phenoxide, huyu oxygen negative hapa itaenda kureact with this, this carbon kwenye R. Ikisha react na hiyo carbon kwenye R, that means huyu R atakuja kujiattach pale. So will result into the formation of ether and not substitution on benzene as how it was expected. Kwa hiyo alkylation can be achieved by using conditions which prevent the oxygen atom from acting as nucleophile. Kwa hiyo tunatakiwa to prevent the oxygen atom from acting as the nucleophile. If phenol is gently warmed, yani tumeiwarm kidogo, gently warmed with an alcohol or alkene in presence of sulfuric acid. If phenol is gently warmed with an alcohol or alkene in presence of sulfuric acid, alkylated phenol will be formed. Unaona bwana? So the presence of an acid catalyst prevents phenol from dissociating, kwa sababu phenol yenyewe ni acidic. Unaona? Kama phenol ni acidic, tukiweka acid nyingine manake itaongeza concentration of hydrogen ions in the solution and thus prevent the dissociation of this. Tenda kusoma pia hii kwenye acid base and salt kwamba kivipi presence ya na mambo ya solubility form 6 solubility, kivipi presence ya ions nyingine zina affect solubility fulani. So it's like that way. Kwa hiyo presence of acid in a prevent phenol from dissociating. The high concentration of hydrogen ions from sulfuric acid does not favor the release of proton from phenolic hydroxide group. Both reactions between phenol and alcohol or alkene involve initial protonation of these two reagents. Yani tunaongeza proton, initial protonation tunaongeza proton. Kwa hiyo kwanza atureactishi na haloalkane, tunareactisha na either alcohol au alkene. Alcohol au alkene in the presence of sulfuric acid, sio in the presence of Lewis acid as how it was expected in the benzene. So for example, unaweza kuona alkylation ya yule pale tunapata huyu hapa na yule pale, or product either at ortho or para position with water, and even alkylation by using this alkene tunapata product kama yule pale. The mechanism for this reaction can be summarized as, first we have sulfuric acid which dissociate to form the hydrogen proton plus HSO4 negative. The important reagent which we need is this proton. For example, if we have alcohol R or then H, then we have hydrogen proton. Here we have two lone pair. What happens here is that this oxygen donates the lone pair in the hydrogen, and the product formed is R, then O, hydrogen. Here we'll be having positive. So kitakachotokea hapa ni kwamba if we have phenol here, na remember we have acidic condition ambazo zina, if you have phenol, ngoja niache niweke tap, we have acidic condition ambazo zinazuia dissociation of hydrogen. So tukireactisha na R, oxygen then hydrogen, what will happen is that ni kwamba huyu bondi atablik, atasupply electrons kwa huyu R, afu huyu R atablik, atasupply electrons pale. So what will be formed ni kwamba we'll have this product. Tutakuwa na product kama hii hapa, ambayo hapa tutakuwa na positive charge, and there tutakuwa tuna hydroxyl pale, positive charge, after the new R atakuja kujiattach somewhere there. So from there huku tutakuwa tuna water at the product, this one itaenda kuform water. Kwa hiyo hii hapa inaweza ikawa neutralized tu, inaweza ikawa neutralized like this way. Huyu alivyokuja hapa kwa kwenye reaction mechanism kutakuwa kuna, remember hapa pia tuko tuna hydrogen, hapa tuko na hydrogen pamoja na R kujiattach, lakini pia tuko na hydrogen. So having this hydrogen, manake this hydrogen can break bond and then can supply here. By breaking bond and supplying here, hii hydrogen itakuja kuwa carried na yule pale. Huyu hapa ata supply electrons to this hydrogen. Hydrogen ata break, ata supply pale. The molecule will become neutral na maisha yatakuwa yanaenda like that way. Kwa hiyo hivyo ndivyo ambavyo inatokea hii reaction. Hivyo ndivyo ambavyo hii reaction inatokea hapo kwenye phenol. Ndivyo ambavyo hii reaction inatokea. So let's see some few examples. Kwa hiyo kwa mfano unaweza kukuta kuna alcohol kama huyo hapa, phenol kama huyo hapa, ana react na alcohol kwenda kutengeneza huyu au huyu, either product can attach at ortho or para position. Lakini pia kunaweza kuwa kuna phenol kama huyo hapa ambaye ana react na alkene product, either attach on ortho or para position. From there let's move to acylation reaction of phenol, ambayo kule kwenye benzene tuko naita Friedel-Crafts acylation, lakini huku ni acylation reaction of phenol. Let's discuss about this acylation reaction. This reaction experiences similar difficulties to alkylation, kama zile ambazo zilikuwa zinatokea kwenye acylation na pia kwenye alkylation na pia kwenye acylation, zinajitokeza pia changamoto kama zile. So involving nucleophilic attack by the phenoxide ion in the acidic chloride to form phenyl alkanoate ambayo ni ester. However, under excess aluminum chloride ambayo ni Lewis acid, or reasonable yield of acylation can be achieved. Kwa hiyo tunachokifanya hapa tunaweka excess aluminum chloride. Excess aluminum chloride itatufanya tuweze undergo hii reaction. So in the presence of excess aluminum chloride pamoja na reflux, tunapata product ambayo inakuwa ni acylated phenol. So when acid anhydride is used, the reaction is termed as Freer's reaction, which involves a complicated mechanism. Frears reaction. The reaction is termed as Frears reaction, which involve the complicated mechanism. Hiyo ni kama tukiwa tumetumia acid anhydride kwenye hiyo reaction yetu. Kama tumetumia acid anhydride, reaction is known as the Frears reaction, ambayo involve complicated mechanism. This gives a high yield of oscillation product. Inatupa high yield of oscillation product. So this is the way the Frears reaction tend to take place. Inakuwa kama hivyo hapo, complicated mechanism. Lakini all in all, what you need to understand hapo ni kwamba hiyo inatupa product nyingi zaidi. Kwa hiyo unaweza kuona tu reagent ambazo zinahitajika. Tunahitaji reagent huyu hapa na tunahitaji reagent huyu hapa. Huyu ni wa kwanza, huyu reagent wa pili, ambaye ni reaction ya mixture aluminium chloride pamoja na huyu hapa carbon sulfide in temperature ile pale. Kwa reagent zenyewe ni nyingi pia katika hiyo reaction yetu. Number 4 is nitration of phenol. Mononitration of phenol is carried out at room temperature by using dilute nitric acid. Due to strong activating effect of phenolic hydroxide, the catalyst ambayo ni carboxylate tuko naitumia kwenye benzene is not necessary. Carboxylate here in this case it is not necessary kwa sababu tayari kuna activation ya huyo benzene ring. So dilute nitric acid at room temperature inatengenezea either ortho or para product. Lakini pia tunaweza kufanya kwa sodium nitrate ambaye sodium nitrate anatupa product pia kwenye ortho or para. If complicated nitric acid is used, if concentrated nitric acid is used, trinitration occurs. Kwa hiyo tunakuwa tuna 2,4,6 trinitrophenol, 2,4,6 trinitrophenol kama tukitumia conc nitric acid. Then sulfonation of phenol. Since phenol is more reactive than benzene, fuming sulfuric acid ambayo inakuwa ni mixture of sulfur trioxide pamoja na conc sulfuric acid is not necessary required for sulfonation of phenol. Phenol will react with ordinary concentrated sulfuric acid bila kuweka mix with the sulfur trioxide. Ina react with ordinary conc sulfuric acid. So with the ordinary conc sulfuric acid ina form two products, either at ortho or para position. Zote ni benzene, ni phenol sulfonic acid, au zote ni phenol ambayo imekuwa substituted with this group, lakini inaweza kawa substituted either at ortho or para position. About the carboxylation reaction of phenol, sodium phenoxide react with carbon dioxide at temperature of 130 and 5 atm, followed by dilute HCl to give 2-hydroxyl benzoic acid au salicylic acid au 2-hydroxyl benzoic acid, ambaye anaonekana kama hivi. Tutaenda kumdiscuss zaidi huyu salicylic acid huko mbele. It is very important for you to remember these reactions kwa sababu utakapokuwa unazidi kwenda mbele hizi reactions tunazitumia. Reactions of phenol with chloroform ambayo ni trichloromethane with a solution of sodium hydroxide followed by dilute acid to form hydroxyl benzene carboaldehyde. Kwa hiyo inakuwa ni phenol ambayo ina aldehyde group attached there to form the hydroxyl benzene carboaldehyde. If carbon tetrachloride is used instead of carbon trichloride or if the tetrachloromethane is used instead of trichloromethane au chloroform wanaita, tukitumia hii hapa tunatengeneza aspirin. So if huyu hapa carbon tetrachloromethane is used instead of chloroform, salicylic acid will be formed, which is used in the synthesis of aspirin. So what will be formed here is this compound, ambayo compound anaenda kutengeneza, huyu ni salicylic acid ambayo hutumika katika synthesis of aspirin. Salicylic acid ambayo imetengenezwa hapa ni yule kama ambaye tulimtengeneza kwenye reaction of carboxylation of phenol kwenye temperature ya 130 na 5 atm, ambayo tulikuwa tunatumia sodium phenoxide. Kwa salicylic acid is used in the synthesis of aspirin, which we discuss it later in the carbonyl compounds.